Welcome to Scaling Up, the podcast where we're scaling up on knowledge so we don't scale up our systems. Hello, Scaling Up Nation. Trace Blackmore here, your host for Scaling Up H2O. And folks, it seems like we have an impossible job. We are keeping things from corroding that want to corrode. We are keeping things from coming out of solution that want to come out of solution. We're keeping things from growing biologically in our systems that want to grow in the systems. And then we have to deal with all the dirt and debris that comes into our water systems. Well, folks, you've heard me say this, and our job is we are heat transfer efficiency managers. No matter what it says on your business card, your job is heat transfer efficiency management. Everything else we do is just a bonus because our simple job is heat transfer efficiency management. Now, I said simple, but there is nothing simple about that. And folks, if you've ever seen me present at the Association of Water Technologies or another venue, you know I always talk to the audience about how they should talk to the customer about heat transfer efficiency. And water treatment is one of those things that every customer wants to know what the price is and how they can get the price down, but that really doesn't matter. Water treatment is cheap when we do our jobs, and that is making sure that that equipment that we are treating, we're called water treaters, but we're really equipment treaters. When that equipment is clean and it can run as efficient as possible, our water treatment costs are minuscule when you compare it side by side with the water savings we can provide and especially the energy savings that we can provide. So I encourage you, always look at yourself as a heat transfer efficiency manager and make sure that your client sees you that way too. Well, one of the 4 items that I mentioned at the top of the show was filtration. Now, filtration is the non-chemical part of what we do. It's the synergy where mechanical meets chemistry. And it has to be there in order for us to be a heat transfer efficiency manager and do that job well. I have found when I speak with other water treaters that filtration is one of those things that is just very misunderstood. I had the opportunity to meet an expert in filtration. I love having this podcast. I have had the opportunity to meet so many people in the water treatment industry. And I got to tell you, folks, I am learning right along with you. So again, if you know somebody that I need to interview, let me know because I love meeting other experts, new experts in the industry, because we are all learning together. And this show is not going to disappoint. I promise that you will come away looking at filtration a little bit differently and have more knowledge for you to talk with your customers and help them make better decisions. Well, folks, let's welcome Bryan Hayward. My lab partner today is Bryan Hayward. And Bryan, I am very excited to talk to you today. I talk about filtration a lot on this show, and it's so awesome to have an expert about filtration on. How are you today, Bryan?
Oh, I'm great, Trace, and thanks a lot for having me. I'm happy to be here.
Well, I am happy that you are here as well. I think filtration is one of those things that is either totally understood by a water treatment professional or totally misunderstood. There's very much gray area between that. So I'm hoping with today's show, we can help a whole bunch of people in the Scaling Up Nation. Are you ready for that?
I hope so.
Awesome. Well, hey, how about you tell the Scaling Up Nation a little bit about yourself as we get started?
Sure. I'm a chemical engineer graduate, and then I got into water treatment within a couple of years of getting out of college. And I worked for a major water treatment, worldwide water treatment company for a number of years. And then I went to work as a sales manager for a regional water treatment company. And I did that for a little over 13 years. So I am basically a water treater who learned about filtration.
I can't think of a better person to be on this episode for that reason.
Yeah, I'm pretty, that's it. I'm comfortable in the world, and I do understand what's important for a water treater. I understand that as a filter person, when I come in there, the first thing I ask any potential customers, who's the water treater, what's his name, and what's her name and phone number. And I get a hold of the water treater, I explain who I am and what I'm doing there, and I ask the water treater to work with me and see if we can't help the customer out in the process. And so that's really important because water treaters are pretty sensitive to the fact of anybody coming in there and starting to tell their customer what they need to do with their water. So I think it's important and it's important for the water treater to work with a filter person and communicate with them and find somebody they can trust, because it's so important to have a trusting relationship for it all to work out. So anyway,
Well, Bryan, one of the doctrines that I've always lived by in water treatment is that every system needs filtration. How do you feel about that?
Well, as a sales manager in a water treatment company, what happened to me is when these high efficiency filtration systems first came out in the New England area, when I dealt with problems with water treatment customers, it's almost always open up a chiller, open up a process piece of equipment. There's deposition, there's corrosion, everything's plugged up and everybody's mad. So that's usually the problem that caused most of my water treaters that work for me to lose their customers. Little by little, when people decided to put filters on the cooling water system, suddenly a water treater could kind of not do a perfect job. And frequently that is, the water treater's only there maybe once a month or once a week. The customer's the one responsible for maintaining the chemical levels. And when they don't do their job, they blame the water treater. So clean water makes the water treatment chemistry work so much more easily. It kind of clears everything out so the chemistry can do its job. So I told all of my guys that they should tell all of their customers to get filters on their cooling towers, because it made more money for the water treaters, basically. We didn't lose anywhere near as many clients if they had clean water.
Well, there's definitely a mechanical leg of what we do as a water treatment professional, where whether we're using chemical products or something else to treat the water, we have to have that mechanical removal of all these particles that just play havoc in our system. And they make it so it's impossible for us to do what we are hired to do. So let's say that I am at a cooling tower and I'm trying to decide what filter needs to go on. Or let me even move back further. How do I even know that I need a filter on that cooling tower?
Okay, the basic concept with cooling towers, I think, as we all know, is that they pass water across air, large volumes of air, and it allows the water to evaporate and cool the water from 95 degrees to 85 degrees or so. So we have to put a lot of air through water. Usually, most often, contamination in cooling water systems comes from the particles that are washed out of the air. So any cooling tower is continually washing dirt out of the air. And it depends on what environment you're in, how bad that deposition can be. And it also depends on a lot of things like cycles of concentration that you maintain and things like that. But generally, a cooling tower needs to have a filter to pull out the particulate in there.
Bryan, let's say there's a water treater and he's relatively new to the water treatment industry, and he's right there looking at the cooling tower, and he's trying to determine not only if a filter is needed, but how to have that conversation with his customer. What should he do?
Well, I think that usually a customer has to believe that there is a problem that needs to be fixed. He's not going to spend money on a piece of equipment, a filter, unless he determines that there's a problem that needs to be fixed. So if this is my account and I'm going in there to look at the cooling tower, maybe looking in the sump to see what that looks like, or looking at a history of corrosion coupon analysis, where is there any evidence that deposition is causing a problem with the customer? When he brushes his tubes, the once a year shutdown that most people have, are the tubes, do they have that little slimy feel in them? Because biofilm, that is the main cause of problems in cooling systems with deposition, because that's where all of the bacteria grows and nucleation for more settling, things like that. And it builds up a film on the tube surfaces or the heat transfer surfaces. And so if you rub that surface, it may look clear because biofilms are generally clear. But if it's a little bit slimy, then you've got a slime on there that's like putting a blanket on the heat transfer surface. So it's along the lines of finding out from your customer what their attitude is about the current situation with particulate in their system, and then explaining to them why there is a problem that needs to be fixed by the use of filtration.
I know we're going to talk a little bit later about ROI and how we can show that customer that an investment today will pay them back in the near future. But before we get to that, I know there are a lot of terms out there that deal in the filtration industry. I was hoping that we could define some of those terms. And one of them is laser particle.
Laser particle analysis is the use of a analytical machine to send laser beams across water that reflect, and you can tell like the size of particles and how many there are. So water treatment companies often have a particle analyzer, or you can send the water sample out to a lab that has a particle analyzer. One of the things about particle analyzers is the ones that are most frequently used cost maybe $8,000 or $10,000, and they are not particularly accurate. The ones that are accurate cost maybe $50,000 or $100,000. So there is a bit of a problem in the actual technology as far as the accuracy goes. But if you use the $5,000 particle analyzer, you'll get a certain reading. If you put a filter on the system, that reading will drop way down and you'll be able to show a major removal of particulates. So any particle analyzer will get you the basics.
Well, Bryan, my question is, if we're going to sell a filter for a cooling tower, is it absolutely necessary that we have this analysis done?
No. I usually get it done just because of my personality, I think. I want to know what's in there. And so it's not absolutely necessary particle analysis done. Most of the time, a water treatment customer, will make the decision to buy a filter when he understands the concept of film formation on heat transfer surfaces and the cost of that to him. That approach to dealing with whether or not I should buy a filter is the key to getting a filter purchased by a customer. That's where all the real big money is, heat transfer efficiency. So that's always where I head.
So if you can convince the customer that they're paying for this, rather if they realize it or not, and the sooner that they get something to take all these particles out so they don't settle and make their heat transfer equipment less efficient, they're going to start realizing the gain from that equipment.
And I used to calculate that, and I've got the formulas for that and everything that I'm happy to send over to you, and you could distribute it to people and make kind of a simple presentation of what happens when you put biofilm formation on a heat transfer surface.
Yeah, absolutely. I'm going to take you up on that. We'll put that on the show notes page so that way the Scaling Up Nation can go there and find that.
Okay, that sounds good. Sure, that's laser particle analysis. Usually the other terms are particle volume, particle count, surface area, total suspended solids. These are pretty confusing subjects that you get when you get a particle analysis result. That can be pretty confusing, and to the customer and to the water treater, because that's easily understood. Particle volume is the total volume of all the particles that are in the water. If you squish it all together and make all those particles into one ball, that's the particle volume. The weight of that particle, that big agglomerated particle that you measure the volume in cubic microns. The volume is the size of it. The suspended solids measurement is the weight of it. So if that ball that you just put together is made of iron particles, then the TSS is going to be really high because it's hard and it's heavy. If that volume is made up of pollen and soft materials that usually get blown in the air, they're all usually really fine particles that float around in the air. That TSS of that big ball, because it's really light material, is going to be very low. So it's not, the total suspended solids in a cooling water system is not all that clear on what's going on. So you want to know what the total suspended solids are, but in most cooling towers, the solids are low because almost everything in the water is very fine, less than 5 microns, and it's usually softer kind of material. So you don't get much TSS on a cooling tower. If you've got contamination from a process, if you've got river water makeup, then you're going to get a lot of TSS. And that's like a whole different technical problem when you've got significant outside contamination, not from the air. Surface area is another thing. The only reason why I make a point of looking at surface area is that when you have really fine particles, the surface area on each particle is significant. And if you push that particle all together into a big particle, the surface area is just the outside of that agglomerated particle. So when you got a big particle in a cooling tower, the surface area of that is nowhere near as big as 1 million half-micron particles, and bacteria lives on those fine particles. So the more surface area, the more bacteria. That's why biofilm is so aggressive, is that these fine particles settle and then the bacteria starts to grow and you've got a problem.
Bryan, at the time of this recording, I am here in the South. I'm in Atlanta, and we have a pollen problem. I don't mind telling the Scaling Up Nation that, and it just wreaks havoc on all of our cooling tower systems. So if we were to do one of these laser particle analysis, it's going to be different this month than, say, it will be in September. So what do you do about that?
It's a seasonal thing. When I, like large clients that have the money to have particle analyses periodically done, like once a quarter, it's really a seasonal thing. Everything changes every season in any significant system, whether it's because of the pollen count or whether it's because of the temperatures outside. The winter cold weather is generally going to have less particulate in it and less problems with the water. The load on the system is usually lower in the winter, so you've got the total volume of air going through a system to be washed out is going to be smaller in the winter. In the spring, a lot of times people open up all kinds of systems that were closed all winter. And when that happens, there's frequently a lot of material coming in. So to me, there's always ups and downs and jumping way up on particles and way down on particles. The trick is if you've got a filter on there, when the particle loading goes up, fairly quickly, within days, a filter will clean up the particulate loading and bring it right back to ground zero again.
Well, let's talk about that next. So we now have our analysis, and now it's time to help choose the right filtration for our customer. What is that process?
Well, I think it depends on what filter company you represent. So, I think everybody's got their own points of view on this. People like me, I've always worked with high efficiency filtration, which is filtration of like 5 micron and smaller particulate, because of the perception and belief by people like me that the really fine particles are what cause the problems in cooling water systems. And so that's what most of the particulate is. When you do a particle analysis, you'll see that there's millions of particles in the 0.5 micron to 2 micron range, and maybe thousands or hundreds in the 25 micron range. So the particles that are larger than 10 microns or so don't float around in the water much. They settle in the sun.
I think the most popular filtrations that I've seen on cooling towers are either a sand filter or a centrifugal separator. Do you mind talking about what the differences are between those two?
Sure. A centrifugal separator is a mechanical unit that depends on spinning the water and causing a centrifugal force to go outside, and the particulate goes out and then agglomerates together and drops down the bottom and comes out. Generally, a centrifugal separator is going to take out 70 micron particles. And so those are fairly large particles. You're not removing any of the pollen, for example, any of the fine particulate with a cyclone separator, centrifugal separator. So water treaters generally don't recommend them. The problem is that they're the least expensive way for a customer to feel like he's removing particulate from his cooling system. But those particles are settling in the sump normally. And the sump is actually the design in the cooling tower. It's a design for stagnant water below the cooling tower so that the particles will settle in, the heavy particles will settle in the sump and they don't get blown around through the system and get on heat transfer surfaces. So the centrifugal separator is not the ideal for a water treater. That's not going to improve your water treatment program. Sand filters are generally two types. Most of the sand filters, if the basic type of sand filter is a 0.55 millimeter sand media, that's what the Unigran 55 is. And usually that's the finest sand particle size that you would put in a single media or multimedia filter. Because when you push water straight down through a filter, the spaces in between the sand is where the particulate gets trapped. And if you have too fine a sand, then the top surface of the sand plugs up right away and you keep backwashing all the time. So sand filter manufacturers have had to limit the fineness of their filtration to something that's practical. So generally like a 0.55 millimeter sand particle will filter down to around 30 microns, which is a lot better centrifugal separators. And because those larger particles produce a lot of the turbidity appearance in cooling water, the water looks a lot better when you put a traditional sand filter on. And that traditional sand filter, removes a significant amount of particulate. There's no question about that. The high efficiency filters are a filter design, it's probably 50 years old now. Those filters, the design of the high efficiency filter is they put 0.2 millimeter sand. So that's compared to 0.55 millimeter sand. So 0.2 is much finer. If you put that 0.2 millimeter sand in a straight, normal media filter, that filter will plug up right away. You can't use that fine sand. So this guy, I think the first guy that came up with it was in Western Mass. And what he did is he ran the water crosswise across the filter bed, which brushes the top surface of the filter bed. And instead of storing the particulate that's removed in the bed, which it does in a straight through filter, a centrifugal force or cross flow type filter, but the cross flow type filter stores all of the particulate up above the bed. So during filtration, high efficiency filters are not plugging up the bed. They're continually brushing the bed. When the area above the bed gets too full of particulate, the particulate starts to settle into the media and the system needs to go into a backwash. So that's the reason why high efficiency works, is because they're constantly brushing, creating turbulence on the top of the filter bed. So half micron filtration then will significantly reduce the pollen levels, all the fine particulate and biofilm formation. So I've always liked high efficiency filters, but any sand filter is better than none.
And I will tell you, Bryan, we're dealing with pollen right now. We have a lot of centrifugal separators that were sold when the cooling tower was sold to the client, and they do nothing for pollen. So you are 100% right about that.
Yeah. I hate to downplay anybody else's equipment and whatever, but the facts are it's 70 micron for centrifugal, 30 micron for single media filter, and 0.5 micron for high efficiency filter. So it's a dramatically different result.
Are there any other filter media types that we should be looking at for cooling towers?
Every once in a while I hear about some other possible methods, but I haven't seen anything yet that works. The company I work with has done a lot of R&D in the last few years, and we've developed some designs that we improve on the high efficiency filtration concept. And we do have some, newer designs out, but it's still cross flow, brushing the top surface of the media and using fine media. I haven't heard of anything that works like that.
Now, if you and I were working together and we were making sure that we put the right size, high efficiency sand filter on a particular cooling tower, what kind of questions would you be asking me?
The key is what's the GPM recirculation rate on the cooling tower? What's the total water that's going to flow through the tower? What's the GPM? And you can get that somewhat from the tonnage. If a standard cooling tower is designed for a 10-degree delta T, and it's a 500-ton chiller, then the design condenser water recirculation rate is 3 times the tonnage, which is like 1,500 GPM. But it's good to go and look at the pump at the cooling tower and see what the GPM rating on the pump is. And then the question is, if you've got several cooling towers, how often do they all run? What is the high load time? During the warmer months of the year, what's the percentage load on the cooling tower? Because that will tell you what the amount of bleed rate coming out of the cooling tower is in order to maintain particular cycles that the water treater's got it set at.
Well, you bring up an interesting point. I know several times we've been invited to a cooling tower and install people just set it up the way it comes out of the box. And we had to dial in the correct backwash, whether it was either on a time, which I don't like, or it was on pressure, which I do like more. And I'm hoping you'll talk about that. We had to dial that in because we were not able to concentrate the water up to where we knew that water needed to be. It was backwashing more than it really needed to, and we weren't able to get the concentration ratio up to where we wanted it until we made some adjustments.
That's a problem that occurs when the tower filter uses the tower water for backwash. If you use city water, or clean water, any kind of clean water into the cooling tower, traditional sand filtration should use the city water and pump that back through the filter to the drain to backwash it. So the only water you're using out of the cooling tower is maybe that little bit of water in the top of the tank when you go into backwash. So that would sound to me like a system that's set up to backwash with tower water.
Well, Bryan, I got to tell you, I've never seen a system that has not been set up to backwash with city water. It's always been tower water. So you are teaching me something today. Normally, they're not installed that way. So what do we have to do as the water treater to get them installed that way? Are there extra valves that we need? Tell us about that.
Well, okay, so it depends on who's buying this filter or who's working with the filtration company. If the water treater is coming on the scene after the purchase of the filtration system has been made, that's not a good plan. To me, I always recommend city water backwash. And in fact, I don't ever put a filter on a cooling tower that uses cooling tower water for backwash. It could be just locally, the places where you are have been sold by a particular filtration company that doesn't really know what they're doing. I shouldn't say it that way, but never ever use cooling tower water for backwash. And so when a filter is ordered, the water treater and the customer need to say to the filter guy, this has to be clean water backwashing. Sometimes you take water from the filtered water and put it into a tank that will be enough to cover one backwash, and you keep that tank leveled up with water from the filter. But you absolutely can't use tower water for backwash. It's bad plan.
Do you have to worry about biological fouling when you store water like that?
Well, it's only going to be there for a day or so. The filter design that I always recommend as far as backwash goes is it needs to be set on a timer to backwash once a day if it hasn't backwashed in the last 24 hours. So it needs to backwash every 24 hours. And the reason for that is that in the media, the particulate that's in there is full of bacteria. And that if you leave that bacteria in there for 3 or 4 or 5 days, you're going to plug up the filter bed, and the filter bed has to be replaced. So backwashing should be done a minimum of every 24 hours to be sure you don't get biogrowth in the filter tank. And then the real control on backwash is whenever the pressure differential gets up to a limiting point, the filter automatically goes into backwash. So generally, the 24-hour backwash timer doesn't even get used, but it needs to be there in case something isn't going right. It's got to be backwashed every 24 hours.
Now, you mentioned media fouling. So we have regular backwash that's cleaning the media, but now eventually the media gets worn out. We got to replace it. What is that process like, and how often should we be doing that?
If the filter's operated properly, and that is 24-hour backwashing, it never goes more than 24 hours, then most of the filter beds that I work with go 10 years without being replaced. You don't need to replace filter media if you don't get biofilming. If the filter's set up properly in the beginning and everything is all set, then the filter doesn't need to have the media replaced, and unless somebody's doing something they shouldn't be doing. So that's the key to the media. When media is replaced every maybe 10 years or whatever, we generally take an industrial vacuum cleaner and suck the media out of there while the water is still wet. Open the cap, let off the pressure, open the cap, let it drain down to near the top surface of the media, and you use an industrial vac and you suck the stuff out of there and put it in drums or barrels or whatever and dispose of it. And then the new media is poured back into the filter. We do that a lot. It's not a particularly big project.
Right, especially carrying wet sand. Nobody enjoys that. At the very bottom of the filter itself, they've got the laterals. And I know whenever you take media out, you're supposed to inspect those. What are you looking for?
Broken laterals. If those laterals are cracked or broken or severely plugged, then you need to deal with it. You need to clean them up or replace them. In recent years, most everybody uses stainless steel mesh as the laterals on the bottom of the filter. The older plastic design, they're more likely to break. But if you've done everything correctly, they don't break either. So it's just a matter I hardly ever have to replace laterals. It's something you need to look at, because if your laterals are broken, you're liable to get media flowing through your filter and out down the drain, potentially even into the cooling tower. So it's important that the laterals be inspected and that they're okay, which is why I generally use stainless steel. I don't use plastic anymore.
That's a great tip. Now, I've worked with people that say, regardless of what the manufacturer says, and some manufacturers say all you have to do is go back with the sand media. They say, regardless of that, you should put some sort of support media down in there first. What are your feelings on that?
Well, I just generally would do what manufacturers say, but I think there's always support media, gravel type material that's used to cover up the laterals, to keep the laterals from getting plugged up with sand. You have different layers of media in a filter to keep the fine media that is used for filtration away from the laterals. That's why you put the stones in there, and it protects the laterals physically from any damage, because you got rocks on top of everything.
Now, where is the best place to install a sand filter on a cooling tower?
Our preference is to put it on a recirculation line, generally like you put a stab in downstream and bring that out to the filter, run it through the filter, and put a stab in 6 feet or so downstream from that point. And what that does is it allows the water that comes into the filter and goes out of the filter, the pressure on the filter in and out is the same because it's on a line 6 feet apart. And so what that does is when you design a filter, you design it with a particular pump and a particular head to get a particular gallons per minute through the filter. And so if you've got varying pressures in and out of the filter, that means you have to add valves, adjust pressures and the rest. And it's very hard to control a filter flow rate through the filter unless you've got pressure the same in and out of the filter. So that's what we generally design. But, when things change, part of the thing is it's nice to have a filter engineer kind of person there who's going to look at the thing and explain what to do with everything. Water treaters shouldn't be responsible to tell people how to do these things. Water treaters always go to me and say, okay, how do we do this? And I explain to the person who's installing it exactly how they have to install it. And we provide drawings and the rest, but communication is really important. When something's installed incorrectly, the filter will not work.
Now, I've seen the use of sweeper jets around the cooling tower basin to try to keep things stirred up. Can you speak a little around that?
Sure. It's opinion, I guess. In my mind, the design of a cooling tower sump, the reason why there's this big sump there that's maybe 12 inches deep or whatever, the reason why that sump is there is because when you bring a lot of particulate into a cooling tower from the air, the bigger stuff, you don't want it to go into the system. You want it to settle in the sump. So blowing water around in the bottom of the sump to keep the sump clear makes it look better to the customer. But you're not removing the particulate, you're sending it into the system. And the idea that if you've got suction in the sump and that you're actually going to be sucking the particulate out, it's just not rational, not technically accurate. It's not. When you create turbulence in the sump, the large, 1,000-gallon a minute flow rate out of the bottom of that sump is taking all that particulate out of there. Your 100-gallon a minute filter is not removing particulate. That particulate is going where the flow rate is. So it's all going in the system. So technically, I don't agree with using the sump sweep concept. It was a nice idea, and it actually helps people size filters because they just do it based on if they put a certain number of jets in the sump of a cooling tower, then the size of the filter is defined by that. And it's not defined by the basic concept of like how much particulate loading is there and what type of system do you have. And the size of a filter should not be defined based on the sump sweep system. So I don't ever recommend the sump sweep system.
Well, the customer's always looking at the bottom of the cooling tower basin, and some look at it more than others. And I always say if there's any more than a 1/4 inch of debris on that basin, it is past due for cleaning. So the question is, and the customer's going to ask this, if I put this filter on, can I extend the amount of time that I have to clean my sump? Or some might even ask, can I just forego cleaning my sump altogether now that I have this filtration?
Yep, that's a good question. The end result of doing this is that the particulate that's settling in the sump, the particulate comes into the cooling tower at like a 1/2 micron. Most of the stuff that's floating around the air is like 2 microns down to a 1/2 micron and some finer. So what's floating around in the air is really fine. So when that particulate goes into the cooling water, it leaves and flows out through the whole system. As time goes along and these particles, you get more and more particles in the water, they agglomerate. And as they agglomerate, the water becomes more turbid, and then the sump begins to do its job of it. Particulate settles out there, but it's also settling in the heat transfer surfaces. So whenever you add a high-quality sand filter to a system, the particle loading in the sump drops by 80, 90%. So any customer that has a particle loading situation in his sump is going to find the sump to be quite clean after he puts a filter on it, because the source of the deposition is being taken away by a side stream filter. So an example of that, I had a cogen plant in Hartford that, you can tell my Boston accent, in Hartford, where they were every year when they cleaned out the sump, they were up to their knees in mud and sludge, and they hated it. Barrels and barrels of stuff to remove. And I told them that I thought that you would reduce the amount of sedimentation by putting a filter on there, but you never know exactly how much you're going to remove it by, because if there's a lot of heavy solids coming in the air, which there shouldn't be, then you could have sump deposition anyway. But what happened to them is the first year after they put the sand filter in, they ended up going into the sump to clean it, and they squeegeed it. No heavy sludge at all. They absolutely love the filtration system. So if you have heavy particle sump loading, it will significantly reduce that. And I wouldn't make promises to my customers, but I would just say, yeah, you're going to be a much cleaner sump, and let's see how it goes. But the reason for buying a sand filter is not so you can clean the sump less frequently. That's a nice thing, but that's just some maintenance expense. It's very short term, a few days, where these particles, when they go into the cooling system and hit the heat transfer surfaces, they reduce heat transfer, and you can cut many, many thousands of dollars a year in electrical use. Increased electrical use is what happens when you have particle loading. And so I keep bringing my customers back to, yeah, we want to reduce the maintenance, but the key is you're going to save a lot of money with the electrical load changes and improvements. And I got a lot of data and sheets on that people can look at too. I can provide all of that.
Well, and we look forward to putting some of those on the Scaling Up show notes page.
The CTI paper that I did, it's pretty old, but the filtration technology hasn't really changed. So that paper you have and you're welcome to put that in the notes. That's about 20 pages of everything I know about sand filtration. So there's a lot of stuff in there. If you want to be educated, and people, you're welcome to put my name and phone number up there and let water treaters give me a call if they have it.
Yeah, we'll definitely put your contact information. If you're on any social media, we will have that on the show notes page as well. Bryan, what's the one thing you want the Scaling Up Nation to get out of today's interview?
If you have clean water, it's going to help the water treatment program keep the heat transfer surfaces clean and with minimum corrosion. If they try sand filters, they're going to love them. And high efficiency sand filters, I think, is a better deal, but it depends on situation and who you're working with and the rest. So.
Well, I sure appreciate you giving some of your filter knowledge to the Scaling Up Nation. But before I let you go, I do have some lightning round questions for you. So are you ready for these?
Oh, God, yes.
All right. So the first one is if you could go back in time and speak to yourself your first day as a water treater, what advice would you give?
I would encourage people I would have told myself, don't give any advice that you're not sure about. Tell people, I'll get you the answer to that. Don't hide that you're new. I just would go into my customers when I was first in water treater, and I'd say, look, I know some chemistry. I know some basic things about chemical water treatment. I know what to do, but I don't know the systems like you do. So if you can help me out with explaining certain things to me, I really appreciate it. Because if you make your customer a person who helps and teaches you, you got a friend. If you go there to give advice to people and tell them how to do stuff, people don't like that. Your customers would rather have you. Yeah. Okay.
I love that advice. That's awesome. What's the last book you've read?
Oh, jeepers. I read mystery novels all of the time, and I study technology online. I haven't really read books on technology in a long time, because any question I have, if I go online, I can ask the question and get it technical.
Yeah, the internet's just ruined book industry for forever, right?
Yeah, well, no, for technical stuff anyway, for me, and for pleasure reading, I still download the books. I read them on my phone. But yeah, everything's on the internet now. Anything technical that I need to know, I can get on the internet in a moment.
Well, eventually Hollywood is going to find out about you. They're going to make a movie. Who played you?
Who plays me? Oh my God, Nick Nolte.
There you go. He's an interesting fellow. That's maybe
Yeah,
very
I
telling.
know. Yeah, it is. Oh, well, what are you going to do, huh?
All right. Well, yeah, we definitely didn't see him come out today on the interview, and I think that's a good thing. He's
Yeah. He's crazy character, but he's my alter ego. Yep.
There you go. My last question is now you can talk with anybody throughout history. Who would it be with and why?
Albert Einstein, theory of relativity. I did a paper on it in high school, and I've always been enthralled with that technical stuff since then. Kind of what caused me to be an engineer.
Well, Bryan, I want to thank you for coming on Scaling Up. Filtration's one of those things that I think most people know they need to have. If they didn't know, they definitely know it after this interview. But you have shared so much information to help shed light on every water treater's need to know, which is filtration. Thank you so much for that. Nation, I know that you got something from that interview. I really think that I could have Bryan on other topics of filtration. He just knows his stuff. Bryan, thank you so much for coming on Scaling Up H2O and sharing with the Scaling Up Nation some of the things that we need to be aware of when it comes to filtration. Now, folks, as you know, as a water treater, we never stop learning. As you've heard me say, my dad used to tell me all the time, the day I thought I knew everything and water treatment was the day I needed to get out of water treatment. And that told me from a very early age that we never stop learning here. And what a great industry to be in where there's so much information out there for us to learn that we never have to stop. And I tell you, when I feel like I've learned everything about a particular topic, I get bored. Folks, I have never been bored a day in my life as a water treater, and it is because there's just so much stuff out there for us to learn next. I encourage each and every one of you to look for what the next thing is that you are going to learn. And with that in mind, we do have AWT's annual convention and expo coming up. It's going to be September 11th through 14th in Palm Springs, California. Now, folks, if you've never been to an AWT convention and expo, I got to tell you, you're missing out. Every person that sells anything that you could possibly need when it comes to water treatment equipment is going to be there. It is the one-stop shop for you to talk to every single one of your water treatment vendors. It is such a value-packed event because you can go to one place and have dozens of conversations. The other thing is there's going to be so many expert presenters there, and they're presenting on topics that are going to elevate what you currently know about those topics. They're going to allow you to get back to your respective territories and be better water treaters because you're coming back with this new information. You're also going to have ideas of things that you can solve based on these presentations. And then, of course, the most important thing that so many people leave out is you are in a venue of people that do exactly what it is that you do. And I talk to people and they say, well, yeah, that's my competition. I don't want to talk to them. Folks, get over that. You are missing such an opportunity. When can you ever go anywhere and tell somebody what it is that you do as a water treatment professional and they truly understand what you're telling them and not think that you're a pool guy or work down at the local sewer? Everybody in this convention hall knows exactly what it is that you do, and you can get some tremendous friendships if you just introduce yourself. I've had many of my friends on the show. You guys know I've had Mark Lewis on several times. Mark Lewis and I do not go a day without speaking with each other. Well, maybe we might go two, but that's not often. And I would not have met Mark had I not have gone to the AWT Convention and Expo. And actually, 2 times ago when we were in Palm Springs where I met Mark. So how about that? We're going to celebrate the place where we met each other. And I've had several requests. People have wanted Mark to come on again. So Mark and I have spoken with each other, so that will be in the near future. But folks, please take advantage of everything that the AWT or any venue where you're coming together with like people, that you're getting everything out of it. Well, folks, so many of you in the Scaling Up Nation have come up to me or sent me an email and said, thanks so much for letting me know about Audible. I've actually been able to read books again. And I know better than anyone, as a water treater, we are behind the wheel so much. So why not have a podcast for the water treatment community? And you folks have been so gracious in downloading and telling people about the Scaling Up H2O podcast, but you've also learned that you can use your car as your personal learning center through the podcast, but then also through using tools such as Audible. Audible is a service that allows you to read while you're driving. Audible allows you to study again. It allows you to learn more, and it allows you to do it on your own terms during your regular day. You don't have to change how your day is. You can just insert this into your day today. Now, if you go to scalinguph2o.com/Audible, I can get you a free month and a free book where you can try Audible out. Now, that's an affiliate site for me, and what that means is it will cost you absolutely nothing extra to go to that site, but Audible, in thanking me, will pay me a slight commission. I thank all those people that have done that, and I thank all the people that have gotten back to me and said what a great tool it is. I'm trying to make sure that anything I let you guys know about, that it has helped me personally, or it has the potential to help the Scaling Up Nation. The thing I'm going to ask you for next is I need your topics. What do you want to hear on Scaling Up H2O, and who do you want me to interview next? Folks, I'm doing a great job of staying ahead of that curve, but once I pass that threshold, I don't want to run out of material. Please help me with this request, and you can go to my show notes page, scalinguph2o.com. You can go directly to the show notes page, or you can click on the voicemail button, and you can actually leave me your information there. And what I'd love for you to do is ask me a question that I can answer on one of our Pinks and Blues episodes. Well, folks, thanks so much for tuning in, and I am looking forward to speaking with you next week on Scaling Up H2O.